Here is a table of the order of magnitude of the electromagnetic spectrum. The order of magnitude of visible light is 10 to the power minus 7. It's also good to keep in mind that the range for visible light is between 700 nanometers and 400 nanometers. Maximum resultant force can be found when both forces point in the same direction. Minimum resultant force can be found when the forces point in opposite directions. 6 newtons and 7 newtons of forces can produce a maximum resultant force of 13 newtons and a minimum resultant force of 1 newton. 12 newtons lie in between these values, therefore the answer is 6 and 7 newtons. The uncertainty can be found by subtracting the minimum value from the maximum value and dividing it by 2. The maximum value is given as 10.70 and minimum value is 10.30. Subtract and divide to get 0.2 seconds. From the principle of conservation of energy, the initial kinetic energy equals to the work done by friction. Once we know this, we can work out the equation for the first block. Here we get half mv squared equals Fd. Do the same for the second block. This time the speed is u and the frictional force is half F. Cancel out the halves to simplify the equation. Equal the Fd together to get half mv squared equals mu squared. Cancel out the mass and rearrange to find your answer. In this question, we are asked to find the magnitude of the displacement of the stone. This will be the shortest distance from the start to where the stone lands. First, use the equation given in the data booklet to find the horizontal distance traveled. The distance can also be found by simply using speed equals distance over time, since the horizontal acceleration is 0. The vertical distance moved is 4.0 meters and the horizontal distance moved is 3.0 meters. Use Pythagoras theorem to find the displacement. You may have also noticed that this is a 3-4-5 triangle. You may know Newton's second law as F equals ma. However, Newton's second law is also defined as the net force equal to the rate of change in momentum. We can express this definition in the form of an equation as shown here. Change in momentum is delta P, and rate means to divide with time. So there you have your answer. Note that if you rearrange a bit and put time next to the force, you get the impulse equation. Also, if you substitute the change in momentum for m, v minus u, you can see how the equation becomes F equals ma. Here are the forces on the two masses. Note that the tension is the same throughout a single string and the magnitude of the acceleration of mass 1 and mass 2 is also the same. The forces on mass 1 has been redrawn here separately. First, let's focus on mass 1. The resultant force is the tension subtracted by its weight. Resultant force is the force in the direction of movement subtracted by the force in the opposite direction of movement. By using F equals ma and rearranging, we get T equals 3 over 2 m1g. This is our first equation. Do the same for mass 2. The resultant force is its weight subtracted by the tension since mass 2 is moving downwards. Use F equals ma, rearrange, to find the second equation in terms of T. Put the two equations together. Do a bit of algebra to find your answer. The aim of this question is to derive an equation that links kinetic energy with displacement. Start off with the motion equation v squared equals u squared plus 2as. We use this equation since the question mentions initial speed, acceleration, and distance traveled. This equation can be simplified since the initial velocity is 0. Substitute v squared into the kinetic energy equation. Since mass and acceleration is constant, this equation equation can be simplified to the kinetic energy directly proportional to the displacement. When two variables are directly proportional to each other, the graph is linear and passes through the origin. Principle of conservation of momentum states that the total momentum of objects in an isolated system remains constant unless an external force is applied. This means that the sum of the momentum of objects before the collision must equal the sum of momentum of objects after the collision. Here are the trolleys before and after the collision. Let us assume that each trolley has a mass of m. For this question, the right direction has been taken as the positive direction. Remember that momentum is a vector. Before collision, the momentum of the left trolley can be found to be 6m. The momentum of the right trolley is minus 4m since it is moving in the opposite direction. Add these two momentums to find the total momentum before collision. The total momentum after the collision will equal to 2m times the velocity of the combined mass. Like we previously mentioned, the total momentum before must equal the total momentum after. Put in the values, rearrange, and cancel out to find the velocity after collision. Principle of conservation of energy states that the total energy before must equal to the total energy after. Total energy is the sum of potential and kinetic energy. Since the car is moving at constant speed, there will be no change in kinetic energy. The car descending a hill means that the gravitational potential energy is decreasing, but then where does the energy go? The energy goes to the work done by friction on the brakes. In other words, the change in gravitational potential energy equals to the work done by friction on the brakes. Due to the friction, the temperature of the brakes increases. The internal energy is defined as the sum of the total intermolecular potential energy and total random kinetic energy of the molecules. And temperature is directly proportional to the average kinetic energy of the particles. Since the temperature of the brakes increases, the average kinetic energy of the particles increases, and if that increases, the internal energy of the brakes increases. Here is a summary of all the information given to us on block X and block Y. Energy will be transferred from block Y to block X since the initial temperature of block Y is higher than block X. Substitute in the equation, rearrange and put in the values, simplify to find your answer. Let's start by analyzing the gradient. Gradient is found by dividing delta y with delta x. In this question, y is pressure and x is per volume. Dividing them together gives us PV. Keep this in mind. Now let's find the gradients. You can use any point on the graph. Here we use the point with 400 kilopascals and 50 per meter cube. This gives us a gradient of 8 times 10 to the power 3. Always be sure to take note of the units of the graph. We start off with the ideal gas equation since this question is asking for the number of moles of ideal gas. We should recognize that the PV on the left-hand side is the gradient of the graph. Put the numbers in, rearrange and calculate to find your answer. The total distance traveled by a particle during one cycle is 4 times the amplitude. The amplitude can be found as 4 centimeters from the graph. The time taken to complete one cycle is the period. Make sure to convert these values into meters and seconds before calculations. To find the average speed, divide the total distance traveled with the total time taken. Put in the values and find your answer. Let's start this question with the intensity equation. The power source radiates light in all directions in the shape of a sphere. Therefore, the equation for the surface area of a sphere can be substituted into the equation. Since the intensity remains the same, the equation can be simplified to the power directly proportional to the distance squared. Here, the radius of the sphere is the distance from the source. For the power to be halved, the distance must be 1 over root 2 times the initial distance away from the source. For interference to occur, two waves must have the same frequency, have a constant phase difference, and travel in the same plane. Since the two waves interfere, the frequency must be the same. The minima of zero intensity refers to the destructive interference. This is when waves completely cancel each other out. It is possible only when the two waves have the same amplitude, therefore the amplitudes also must be the same. When unpolarized light passes through a polarizer for the first time, the intensity is halved. The angle of the polarizer does not matter. This is a fact, so make sure to keep this in mind. Therefore, the intensity graph would have a straight line at half the intensity for all angles. Here is a diagram of light traveling from glass to paraffin at critical angle. We know that the angle of incidence is the critical angle since the angle of refraction is 90 degrees. The refracted ray traveled on the boundary between the glass and the paraffin. Use the equation given in the data booklet to solve this question. Rearrange, put in the values, and simplify to find your answer. The wavelength on a standing wave can be determined by the distance between three consecutive antinodes, or three consecutive nodes are shown in the diagram here. Distance between two consecutive nodes, or two consecutive antinodes, is half a wavelength. The question tells us that the distance between the first and the fifth antinode is 60 centimeters. Therefore, the wavelength is 30 centimeters. The question tells us that the two charges are oppositely charged. Oppositely charged particles attract each other. Therefore, the force on Q must be towards the left. You may also think in terms of Newton's third law of motion, which states that when two bodies interact, they apply forces to one another that are equal in magnitude and opposite in direction. The direction of the electric field for point charges are shown here. Let us consider P as a point and focus on Q. Since the direction of the field is away from Q, the charge of Q can be concluded to be positive. This means that charge P is negative. Now let us consider Q as a point in space and focus on the negatively charged P. Electric fields are directed towards negative point charges, therefore the electric field on Q is towards the left. The electric field is directed towards a negative point charge and away from a positive point charge. Here are the 3 point charges given in the question. Let's focus on 1 point charge at a time. Due to the positive point charge on the top left, the field at P will be towards the bottom right. Due to the positive point charge on the top right, the field at P will be towards the bottom left. And due to the negative point charge at the bottom, the field at P will be towards the bottom. Here are all the fields shown in one diagram due to the 3 point charges. To find the resultant field, join all the fields head to tail in any order. Draw a line from the beginning to the end to find the resultant field. Let's start by calculating the total resistance between the 4 resistors. First, the 2 resistors at the top and bottom part of the circuit can be calculated separately to find the total resistance in series. Then use the equation for resistors in parallel to find the total resistance. It turns out that the total resistance is R. The circuit from the question can now be simplified to having just a single resistor with resistance R. Since we know that the current in the circuit is 0.60 amperes, here, we can calculate the EMF of the cell using Ohm's law. The EMF of the cell is 0.60 R. Now the resistance of the variable resistor is set to 0. This means that the top part of the circuit now only has one resistor with resistance R. Let us find the new total resistance as we did before. First, calculate the total resistance for the bottom part of the circuit. Then use the equation for resistors in parallel to find the total resistance. The new total resistance is 2 over 3R. The new circuit can be simplified once again to a circuit with one resistor with resistance of 2 over 3R. To find the current, use the same equation. Put in the values for the EMF and the total resistance that we found previously. Cancel out and simplify to find your answer. Let's first have a closer look at the question. Same material means that the charge density is the same. Connected in series means that the current is the same. Electrons pass through both cylinders, meaning that the charged particle is also the same. All the information has been arranged here. Put these values into the equation given in the data booklet. Divide equation 1 with equation 2. Cancel out and rearrange to find your answer. When the string is horizontal, the centripetal force on the ball is the tension in the string. Use the equation given in the data booklet. Substitute centripetal force for tension. Put in the values given in the question to find your answer. Photons are emitted when electrons in a higher energy level transition to a lower energy level. The wavelength of the emitted photon can be seen on an emission spectrum. The energy of the photon equals to the energy difference between the energy levels. This means that the larger the difference in energy levels, the shorter the wavelength of the photon, as we can see from the equation given in the data booklet. Here is another electron transition, but this time from a higher energy level. On the emission spectrum, we can see that the emitted photons have a shorter wavelength. However, in this question, we are looking for a transition that gives rise to a photon with longer wavelength. Smaller energy transition than E3 will emit photon with a longer wavelength. The only energy transition that is smaller than E3 in this question is E4. The rate of radioactive decay is exponential. Refer to the radioactive decay curve to help you remember this. Radioactive decay is spontaneous. The decay does not depend on external conditions such as temperature or pressure. And lastly, radioactive decay is random. It is impossible to know which unstable atom will decay next or the exact time it will decay. All these are facts, so be sure to have them memorized. This means that all the 3 statements given in the question are correct. The observed count rate includes the background radiation. The 20 counts per second is included in the 180 counts per second. In this question, we need to find the expected count rate after 30 minutes. The final count rate must include the 20 counts per second of background radiation. Half-life is the time taken for the count rate of a radioactive sample to be reduced to half its initial value. Since the half-life of this radioactive sample is 10 minutes, 3 half-lives passes after 30 minutes. Now let's find the count rate after 3 half-lives. Start by subtracting the background radiation from the initial count rate. When 1 half-life passes by, the count rate will reduce to half its initial value. Do this 2 more times to get 20 counts per second without the background radiation. To find the final answer, add the background radiation back to the final count rate. This makes the expected count rate of the sample to 40 counts per second. Let's start by reminding ourselves of alpha decay and beta minus decay. Alpha decay is when an alpha particle is emitted from the nucleus of an unstable nuclei. This results in the nucleon number and the proton number of the new element decreasing by 4 and 2 respectively. Beta minus decay is when a beta minus particle and an anti-neutrino are emitted from the nucleus of an unstable nuclei. This results in the nucleon number remaining the same, but the proton number number of the new element increasing by 1. When uranium-238 undergoes alpha decay, it produces a nucleon with 234 nucleons and 90 protons. Let's call this element A. When element A undergoes a beta- decay, we get a new element. Let's call this Q. Element Q has 91 protons and 234 nucleons. To calculate the number of neutrons, subtract the number of protons from the number of nucleons. Power equation for the wind generator can be simplified to power directly proportional to velocity cubed. This is assuming that the area and the density is constant. This means that if the wind speed decreases by 1/3, the power will decrease by 1/27. To summarize, the power of the wind before passing through the generator is P. Power after passing through the generator is 1/27p. Subtract these two from each other to find the power absorbed by the wind generator. Use the equation given in the data booklet to find the efficiency. Here, the useful power out is the power absorbed by the wind generator, and the total power in is the power before passing through the wind generator. Put these two values into the equation and simplify to find your answer. Statement 1 is true. Plants undergo photosynthesis, which reduces the carbon dioxide in the air by combining with water to make glucose and oxygen. But loss of forests mean that the carbon dioxide in the air would not be reduced as much. Statements 2 and 3 are also true. Methane and nitrous oxide are greenhouse gases which contributes to global warming. Note that carbon dioxide, methane, nitrous oxide, and water vapor are the main greenhouse gases, so be sure to remember them. The albedo equation given in the data booklet can be combined with the intensity equation. Instead of calculating albedo in terms of power, it can also be calculated in terms of energy or intensity. Note that scattered means reflected. The two values we need from the question is the incident intensity and the reflected intensity. Put these two values into the equation to find your answer.